All right, let's get right into it. And look, this isn't just another story about a software update or some slightly faster AI chip. No, what we're talking about today is a complete, fundamental reformation of AI. Seriously, it's a shift in the entire paradigm, kind of like when we all realized the Earth wasn't actually the center of the universe. It's that big.
And this quote it nails the core idea perfectly. For the last decade, we've all been obsessed with the AI model itself, right? Its parameters, its training data, how big it is. We've treated it like it's the sun in our little solar system. But this new way of thinking says, nope, we've had it all backwards. The physical, measurable world, reality, that's the actual center. And it's about time AI started orbiting it.
You know what's really fascinating is the timing of all this. One of AI's absolute pioneers, Yann LeCun, just made a massive move. He left Meta to start a brand new company called AMI Labs. Now, you just don't make a move that big unless you're convinced the whole industry is about to slam into a wall, and you think you've got the blueprint for how to get over it.
So, to really get this new blueprint, first, we have to diagnose the problem with the AI we have today. We hear a lot about AI hallucination, but we usually treat it like it's just some bug we can patch. But here's the thing, it's not a bug at all. It's a core feature of its design. Current AI is basically a brain in a jar. It's totally trapped in its own head, with no real connection to the world.
Okay, so the fancy technical term for this is topological closure. But let's forget that for a second. Here's a much easier way to picture it. Imagine a brilliant librarian who has spent their entire life in a huge library with absolutely no windows. They've read every single book ever written on meteorology. I mean, they could describe a thunderstorm with perfect poetic detail. But if you walk up and ask them, hey, is it raining outside right now? They have no clue. Literally no way to answer.
And that's the absolute heart of the problem. It's a self-referential loop. The AI checks its own predictions by checking them against other predictions it has stored. It's like a snake eating its own tail or a hall of mirrors with no way out. There's no external objective standard, no ground truth to check its knowledge against.
In the language of information theory, what this means is that the mutual information between the AI's brain and the physical world is just about zero. And that is a genuinely terrifying thought when you realize we're starting to plug these systems into really high-stakes fields like healthcare and finance. Their connection to our reality is basically a flat line.
So how do you fix a problem that big? How do you smash the jar without hurting the brain inside? Well, the solution is this incredibly elegant concept called a topological puncture, and it borrows a really powerful idea from the way the internet itself is built.
Now, I know this slide looks a little complicated, but don't worry about the symbols for a second. The core idea here is actually something we all use every single day: the internet. You see, for your computer to connect to a website, it needs two addresses: a temporary, logical IP address and a permanent, physical MAC address that's burned right into the hardware. This new AI architecture does the exact same thing but for concepts. It says every single idea needs two parts: the abstract concept of a chair and a verifiable cryptographic receipt for a specific chair in a specific place at a specific time. This is the moment our librarian finally gets a window. That's what the puncture's all about. It's a function that injects these cryptographically verified facts, these real-world receipts, directly into the AI's abstract mind. It creates this permanent, unbreakable bridge between the idea of a thing and a verified instance of that thing. And that breaks the closed loop for good.
And doing this fundamentally rewires the AI's entire reward system. Again, you don't need to be a math whiz here. Just get the shift in its motivation. Instead of only getting rewarded for sounding fluent and human-like, its core objective is changed. It's now forced to optimize for both abstract consistency and, crucially, physical accuracy. It learns to value being right over just sounding right.
Now, you might be thinking, okay, this sounds like a huge change. Is the industry really going to do it? I mean, there's a lot of inertia, right? But the argument here is that this shift isn't just a good idea, it's completely and totally inevitable. There are three powerful independent forces that are all converging to make it an absolute necessity.
These three forces are basically creating a perfect pincer movement, squeezing the old way of building AI from all sides. You've got the laws of physics, the laws of man, and the laws of nature. And guess what? They are all pointing in the exact same direction.
So, first up, pure, simple physics. Think about current AIs. These dense architectures. They're like these massive bonfires, just burning through energy. We're talking up to 100,000 watts for a single complex query. It's insane. Now compare that to this new sparse architecture. It's like an LED bulb. it uses just 1 watt. 1. That is a 100,000 times efficiency gain. And you know, basic physics tells us that systems always move toward the lowest energy state. You just can't fight the laws of thermodynamics forever.
Force number 2. The lawyers are coming. New regulations like the EU AI Act are demanding explainability and deterministic audit trails for any high-risk AI decisions. So if an AI denies you a mortgage, regulators are going to want to know exactly why based on what specific verifiable facts.
And here's the core legal problem for our brain in a jar. You simply cannot regulate a statistical guess. A black box that just says, well, the probabilities just kind of lined up this way, is not a legal reason. But a system built on these cryptographic receipts for reality, that can provide a verifiable, auditable trail for every single decision it makes. This makes the old model pretty much legally uninsurable for any critical application. And finally, and this one's my favorite, we have the proof from biology itself. The peregrine falcon is the ultimate grounded intelligence. It dives at 200 miles an hour, making real-time calculations to catch a moving target. If it hallucinates by even a fraction of an inch, it starves. In nature, there is a zero-tolerance policy for being wrong.
So how does it achieve this kind of perfection? With a brain that is 99.999% sparse. It's hyper-efficient. It proves that true operational intelligence isn't about having the biggest, most powerful brain. It's about having the tightest, most efficient loop between a prediction and a real-world verification. You see, survival is the ultimate fact-checker.
So what does all this actually unlock? What happens when you smash the jar and ground the AI in reality? You get a fundamental shift in its behavior. You get a machine that moves from just guessing to actually knowing.
Here's how it works in practice. The AI's knowledge is stored in what's called a sparse data structure. Just think of it like a giant library card catalog. But here's the absolute key. Most of the entries in that catalog are intentionally left blank. A fact is only written down if and only if it has been cryptographically verified against the real world.
And this enables a kind of immune system against lies, which is called active refusal. When the AI is asked a question and finds a blank entry in its catalog, it doesn't just make something up. It refuses. But, and this is the cool part, that refusal isn't an error. It's a trigger. It launches a query out into the real world. It pings a sensor, accesses a database, to go find the true, verifiable answer. It becomes an active investigator, not just a passive storyteller. All of this leads to a really profound redefinition of what we even consider intelligent in a machine. You know, we've been trained to think intelligence is having all the answers, but this new architecture moves us away from a know-it-all AI that confidently makes stuff up and toward a learn-it-all agent that actually understands the limits of its own knowledge.
And so we get to this crucial point. The phrase, "I don't know," is no longer a sign of failure. It is the single most important, most intelligent thing this new kind of AI can say. It's the trigger for a verifiable, deliberate search for truth. It is the sound of the machine finally waking up to the world outside, the sound of that glass jar finally smashing.
So this entire shift is really about moving AI from being a simple autocomplete to being truly autonomous. We're graduating from just predicting the next word in a sentence to predicting the next state of the real world and then acting on it with verifiable truth. And that leaves us with a really fascinating question. What happens when our most powerful tools stop just talking about the world and actually start participating in it?